Measuring an angle using degrees has some historical significance, but is not very convenient when considering that it was developed during a time when base 60 or sexagesimal number systems were more common. There was an effort to use a measurement system that is convenient with a decimal numerical system known as gradians, but many of the common angle measures and values in degrees are not conveniently expressed in gradians, such as 30 degrees, 60 degrees, and 45 degrees that we will use a lot in this course. So the system for gradians is not considered part of SI, or the International System of Units. Instead, we have a system of measuring angles that directly relates the length of the arc subtended by the angle measure to the radius of the circle. If you recall the circumference of a circle formula, which is c equals 2 pi times r, or the radius, we can isolate the constant of 2 pi to get the following. 2 pi equals c divided by r. This is what happens when you divide both sides by the variable r. This means that the constant 2 pi defines the ratio of a circle's circumference to its radius. For any given central angle measure, we'll call it theta for now. We like to use Greek letters for many of the angle measures in this course. We can then say that theta should equal the ratio of the proportional arc compared to the radius. Theta would equal s, which we refer to as the arc or arc length, divided by r. If you want to think about this visually, using my crude drawing of a circle here, we can consider that 2 pi is the ratio of the circumference, or the entire length of the outside edge of the circle, compared to its radius. That's what we can think about what 2 pi represents. Well, what if we're not going a full way around the circle? What if I'm only going half the way? So for example, if I'm only tracing from here all the way over to the opposite side of the circle there. Well, that means I have gone now half of the circumference, meaning that whatever this angle measure is, can be thought about as the ratio of 1/2 of the circumference, but the radius has not changed. Or maybe if I'm not going half the way around the circle, let's say I'm going 1/4 of the way. So I go from the initial point, and I'm now facing up at like the 12 o'clock position. Well, now this means that I have not gone half of the circumference, I have now gone 1/4 of the circumference. Depending on how much of the circumference we are traversing, in proportion to the radius of the circle itself, we can define that as our angle measure, theta. This is how radian measure is developed. We refer to the radian measure for an angle as how many radius lengths we need to sweep out along a circle to subtend the angle measure, theta. An important note about working with degrees and now radian measure. Because we now have both degree measure for an angle and radian measure for an angle, make sure that your calculator is in the correct mode when selecting degrees or radians. Most calculators have a mode button near the top that will allow you to change the mode appropriately. For example, in this picture for a TI-34 calculator, note that the screen already indicates to me that I am in degree mode currently. This can be a very big problem for a lot of the functions that we will introduce in this course that rely on either being in degree or radian mode. To adjust this, there is a mode button near the top of the calculator, which will open up another menu allowing you to select between degrees, radians, and depending on the calculator, sometimes also gradians. Make sure that depending on what you are working with, that you have the calculator set in the correct mode. With what has now been established for both degree measure and radian measure of an angle, we should now be able to convert between both degree and radian measure. If we consider that one full rotation is 360 degrees, and that we also know that one full rotation in radians is 2 pi radians, we should now be able to make a ratio between them. That 360 degrees is equivalent to 2 pi radians, in a similar way as 1 meter is equal to 100 centimeters. Or we can also make this a little bit simpler, since both sides of this equality involve an even number. We should be able to divide both sides by 2 and instead say that 180 degrees is equal to pi radians. Using this information, we now should be able to come up with the conversion factor to convert between degree measure and radian measure. If we are converting from degrees to radians, we will multiply by pi radians divided by 180 degrees. Whereas if we're converting from radian measure to degree measure, we will multiply instead by 180 degrees divided by pi radians. As a quick example, if we take the degree measure 120 degrees, if I want to convert 120 degrees into radians, I will take this measure and multiply it by pi radians divided by 180 degrees. This will eliminate the degree measure and allow us to get 120 pi over 180 radians. Or if you simplify that, since both the top and the bottom have a factor of 60 in common, you can simplify this to 2 pi over 3 radians. If you wish to convert back, you can then take 2 pi over 3 radians and multiply that by 180 degrees over pi radians. This will allow us to eliminate the radian measure. If we do 2 pi times 180, that will give us 360 pi over 3 times pi is 3 pi. This will be an amount in degrees, or if you simplify by canceling both pi in the numerator and denominator and factoring a 3 out of both the numerator and denominator, you will get 360 divided by 3 is 120 degrees.